Question on the last one.
Yep.
When you click on edit, sometimes I think the other one is grayed out. I don't think you can change push.
Oh, yeah. Yeah, so if you do edit, if you untick this right here, then you can change them separately. Okay? So let me go back to where I was. Branches. Okay? So how do I get PS3 branch into here? Right. You look at the remote branches. And the remote branches, the remote knows about master, PS2, and PS3. Now, it may be that you look here and it doesn't say PS3, because it doesn't realize, it doesn't look at the remote unless you tell it to. So it probably is not going to realize that PS3 is a branch on the remote. So what do you do if you don't see PS3 here? That's when you need to go back and go to sync and just do a fetch. That just lets your local repo find out what's on the remote. Okay? And if you do that, then you should be able to switch back to branches, open this up, and you will see PS3. You know, I saw PS3 because I fooled around with this before class. I didn't really set it back to the way it would be in your case. And then you just double click there, and that adds that branch to your repo and checks it out. So you can see that folder is checked out. Now, what does it mean that the repo is checked out? Or that not the branch is checked out? What's that term mean, checking out a branch? Yeah?
Does it mean the one you're making changes on or working on?
Right, it's your working copy now. So if I go, you know, back here, it shows me these are all the solutions that are at the, you know, at the end of that branch. And I can click on one, and then I'm working on it now here in Solution Explorer. Okay, so there's a dependency graph PS3 development test. I'm on that branch. You know, if I go back to the old branch, then I go look what's there. It's completely different. And if I looked on my hard drive in the spreadsheet folder, it would be completely different. That's the way it works, is it completely changes what you're working on when you switch branches. And you don't want to, if you make a change, you don't want to switch branches until you commit the change, or you'll really insist on switching branches when you have the changes, you'll lose the changes. Yeah?
Do you ever have to poll?
Effectively, when, I mean, strictly speaking, when you're using Git from the command line, you would pull. But in the case of this this demo here, where I was getting a new branch, it's automatically doing the Git for me behind the scenes. So double clicking does the pull and the checkout.
Is checking out similar to polling then?
Now, pulling is when you get information from the remote repo into your repo. So, for example, on PS2, a lot of students are working on PS2, and they got the branch down to their repo, and then I realized I made a mistake, and I sent out mail. So they had to pull again. They had the branch, they just had to pull the latest commit down. Okay? That's what pulling is. Checking out has nothing to do with the remote. It just has to do with your local repo. It says, which branch am I working on? Actually, which commit am I working on? You can check out an old commit and look at it. So there, you had the question over here. Did that get at it? So you don't reclone to get PS3. You just make sure you get that branch down into your local repo. Okay? So that works. Eventually, we're going to have to merge. So you got PS2 and you got PS3. They're two classes we need for the spreadsheet. Eventually, we're going to have to merge those branches. And that'll be another thing. So in addition to, you know, as we go on and you're using C# and building more and more of a spreadsheet, I'm having to use more and more of Visual Studio. Now, while we're on the topic, let's look at this formula.cs class. And I just want to point out, you can right-click and say Open Containing Folder. And that takes you to the folder that contains formula.cs. And so, you know it. How do you know that this folder contains a C# project? Yeah, it's this CS_proj file. So that's the configuration file for the project. And if I right-click on it and open it in Notepad or something, you can see it's some XML that it contains your references, and it contains a link to the source file, and it contains properties you've set, whatever. That's where it saves stuff about the project. And you don't have to go in and look at that stuff. But what you should know is, suppose you don't like the name of that file right there, formula.cs. What's going to happen if you change it? Suppose I go and rename it. I'm going to call it formula.x.cs, just because. Okay? I've renamed it. What's going to happen? Yeah?
Needs to change the name of the class.
Well, yeah, actually, the name of the file doesn't have to have anything to do with the name of the class, so I don't have to change the name of the class. Well, let's go back and see if it caused any problems here. Okay? What do you notice there? It's got that red X next to it, and it says it can't find it. The problem is that formula, CS proj here had a, I won't show you again, but it had formula.cs in it. It had a reference to formula.cs in it. And I've changed it, it can't find it anymore. So you don't want to be coming out here in Windows Explorer and renaming things out from under Visual Studio, or it won't be able to find things. Now it's happening again. What do you do if you want to change the name of a file? You come here, you change it inside Visual Studio. And that way it will change it in the configuration file as well. Now, most students don't go out and try to change the name of their C# file, but they will do this. You'll see here it says formula and formula simple tests. So if I go back to that, I don't know what happened to it. I'll open it again. So I'm going to open containing folder. Here's the spreadsheet. Back up again. So you see .git there. So my spreadsheet is the local repo. .git is where all the Git stuff is stored. You don't want to go mucking around in there. That's where all the commits and branches, that's your local repository. And what's in this folder besides .git is all the stuff that's checked out right now. And spreadsheet is checked out. If I drill in, you'll see there's dependency graph, and there is PS3 development tests. And also here's formula, and here's formula simple test. It's kind of an annoying aspect of that they are left behind. I was expecting those folders to be empty. Oh, never mind. I forgot what branch I was on. So yeah, I got formula and formula simple test over here, but dependency graph is sitting there with some empty folders in it. So sometimes, as an artifact of using Git, you'll end up with empty folders laying around. You can delete them if you want. My point is, sometimes you'll create a project and give it a bad name from the beginning. So let's come over here and let's add a new project. And let's say I mess up and I call it Class Library 1. I forget to give it a name down here. So I just, or rather here, and I call it Class Library 1. And I say OK. And it shows up in here as Class Library 1. And you realize, oh, I made a mistake. So I want to rename it. So I go and rename it. And I call it, what I really meant to call it, which was foo. And you're happy until, once again, I closed it. Open containing folder. I go to the spreadsheet, and it says Class Library 1. So the symbolic name has changed, which means inside this spreadsheet.sln is the configuration file for your spreadsheet solution. And if I open it with Notepad, you'll see it has configuration information for the solution, and somewhere in here it's referring to, I don't know exactly where, to that project we just added. So it has a symbolic reference to Class Library 1. So it's displayed by the name you want in Visual Studio, but the folder itself is called Class Library 1, and the configuration file it contains is foo. And that bugs people no end. They really want this folder to be named foo. And so eventually they give in and they come out here and rename it, because there's no way to rename it in. Where's rename? There's no way to rename it inside Visual Studio. Well, what's going to happen when I do that?
No idea where to find it.
Now this SLN file, which has a reference to that folder, is not going to be able to find it. So we go back to Visual Studio, and it can't find that. In fact, it can't really find food. So what if you really insist, you really want that folder to be called food, because it just offends you? Actually, it bugs me too. What would you have to do? Yeah?
You can edit the solution files in the text editor.
Right. You go here to Notepad, and we're going to search for class library 1. I can't find it. How is that? I'm doing something wrong here. Let's make sure I got the right thing open. So here's that. I'm going to open the containing folder. I am going to move up to spreadsheet. I'm going to open up this. Notepad. And it's not showing up for some reason. Well, it's I don't know what I've done to mess this up. But you can, in principle, rename the folder and then go into that SLN file and change the folder name there too. But you see, I've already screwed something up. Yeah.
Do you need to change this folder name in the file store back to just like it was before?
Yeah, he's suggesting maybe I need to go change the name of the folder back so it'll show up in the solution file again and then change it again. My first bit of advice is don't worry about it. If the folder's called the wrong thing, it's just called the wrong thing. We'll still be able to find it in Visual Studio. But if you really insist, you can change the folder and change the configuration file. But be careful to change the configuration file. You don't change the wrong thing. You see, I've already gotten to a spot I don't understand. Okay. So I just want to say this stuff because I get lots of questions about disasters that happen. People say my code has disappeared. Sometimes their code disappeared because they went to a new branch, and they'll reappear when they go back to the old branch. Or sometimes code disappears because you rename something and Visual Studio can't find it anymore. Yeah?
Why would Microsoft make it so that you can't just, why wouldn't they have some kind of part of their user interface that lets you change it?
I don't know. It seems to me that when I change the name of the project, it ought to change the name of the folder while it does in the process, and it bugs me that it doesn't. And I've edited those SLN files more than once for that very reason. Okay. All right. This zooming in is annoying me here. Let me get out of it. Okay. Next order of business. So you're working on PS3. So you're creating a dependency graph class. And I'm getting lots of questions, which I always do, I expect it, about what should the dependency graph do in this situation or that situation. And I want to impress upon you that the specification is completely transparent and clear. It's not, I haven't written to be vague, I haven't written to be tricky. But what students tend to do is, when they have a question about how their dependency graph class should work, they think in terms of their implementation, not in terms of the specification. And you can tell that when a student says, what happens if I need to add a dependency from A to B and my dependency graph does not contain A? Okay? I've gotten that 3, 4, 5 times over the weekend. Okay, they got a dependency graph, they're supposed to add a dependency from A to B and the graph does not contain A. Or, let's put it another way, let's say they're supposed to remove all the dependencies from A to B, all of A's dependents, and A is not in the dependency graph. What is wrong, what is imprecise about the statement, the dependency graph does not contain A? Yeah?
Their implementation is wrong somehow. And
Well, yeah, he's saying the implementation is wrong somewhere. How? It's not, let's forget about the implementation. Why is that a question you would never ask about a dependency graph? Saying that, why would you never say the dependency graph does not contain A?
Because you would make it and add it.
Say it again?
You would just add it to your dependency graph
Okay, yeah, but why is that a bad question? Why is it wrong to say dependency graph does not contain A?
Dependency graph is always a set of two things that
Right.
relate to each other.
A dependency graph is a set of ordered pairs. That's how you abstractly think about a dependency graph. The problem is you may be representing your dependency graph with a hash table. And when you say the dependency graph does not contain A, what you're really saying is, I don't have a key A in my hash table. Okay? That's your problem. That's not, you have to understand your representation. But if you're asking about how a dependency graph should behave, you need to ask about it in the abstract, not in terms of your particular representation. Okay? So, first thing you realize is, to understand the specification, first you have to read the comment at the top of the class. And here's, I don't know if this is all of it or not, but it says a dependency graph is a set of ordered pairs of strings. And I point out that two ordered pairs are equal if and only if their constituent strings are equal. So that's what a dependency graph is, an ordered pair of strings. And then I go on in that comment to define two things, dependence of S and dependees of S. And it says here, if S is a string, the set of all strings T such that ST is in the dependency graph is called the dependence of S. And similarly, backwards way, I get dependees. So I'm not referring to any particular way of representing a dependency graph. I'm just saying when you're trying to decide what a method is supposed to do in some strange situation, you have got to conceive of the dependency graph as a set of ordered pairs. And you've got to understand what these two sets are. Okay? Don't think about your representation. Think about the abstraction. Your job is to make the representation, your job is to make it look like what you have created is literally a set of ordered pairs. You don't have to use a set of ordered pairs, and in fact you shouldn't. It would be too inefficient. Okay? So that's the first thing. Have in mind what a dependency graph is. Set of ordered pairs, and we got these two things defined. So here's the specification of get dependees. And there's my comment. It says enumerates dependees of S. So what does that mean? Yeah.
It finds the string S and finds all the things that...
You said finds the string S. Again, the dependency graph is just a set of ordered pairs. There's no finding a string. All there are to find are ordered pairs. Yeah?
It gets the T and the ST ordered pair and returns all the S's such that ST exists.
Okay. So it returns dependees of S, and we go back and look at what dependees of S is. It's the set of all strings S such that ST is in the graph. So it's going to look for all ordered pairs that end in T. The second thing is a T. It's going to take the first element of all those pairs, get the set, and return that. Okay, so it's always think in terms of operations on ordered pairs. Now, what this may mean in your representation is you go look up T on a hash table or something and return its value. But that's not how you ask a question about the behavior of a dependency graph. You ask it in terms of the specification. Think in terms of specification. Okay? So it should enumerate the set of all strings T such that T of S is in the dependency graph. I may have said that backwards before, but... Now, it returns an IEnumerable. And again, I know students that just run for the hills when they see IEnumerable. I don't understand why. What does it mean when it says it returns an IEnumerable? Say, yeah?
It's returning a set that can be iterated over.
It's returning, he said, a set that can be iterated over. It's returning a collection. Basically, it's returning a collection that implements this interface. It can be a set. It could be a list. It could be a linked list, an array list. It could be, a hash set, tree set. Or you could implement it using that iterator pattern that I showed you. That's another way to create one. But you don't have to. You can just return a set. The set implements the interface. Now, all anyone can do with that thing is iterate over it. So that's why it doesn't matter if it's a set or a list, as long as there's a way to go through the elements. Don't let that freak you out. It's just a common thing you return. Okay, what about this specification? Removes all existing dependencies of the form RT. Then for each string in this incoming set, adds the dependency S comma T. So I've gotten this question more than once. What do we do? The question is always of the form, what do we do if T is not in the dependency graph? Okay, and again, that's not the right way to talk about a dependency graph. You've got to talk about it in terms of ordered pairs. So what if there is no ordered pair of the form R comma T? That's how the question ought to be phrased. What if there is no dependency of that form? What should this method do? Should it throw an exception? Should it do nothing? Is this vague? Yeah.
Just add all the new dependencies. If none of the ones before exist, there should be nothing, and then just add all the new dependencies.
Right. It removes all existing dependencies of that form. If there aren't any, good. It's easy. But you still go on to the next step. After you've removed everything, even if that didn't involve removing anything, because there weren't any, you still need to add those things in. So deciding what these methods ought to do is easy, or easier, if you think in terms of the abstraction, not in terms of your implementation. So you need to think abstractly. And I just want to emphasize, now you may be tempted just to have your dependency graph be a set of ordered pairs. And then then the specification tells you exactly how to implement the class. But the problem is it's going to be hopelessly inefficient. What's going to be inefficient about, let's say that there's 100,000 dependencies, 100,000 ordered pairs. Why would this be inefficient? Yeah?
You have to go through every ordered pair to see if it has like, we have to make sure that both parts match, I guess.
Yeah. If you say you're looking for every ordered pair whose second item is a particular string, you're going to have to look through all of them to find it. Right? So that's just going to take too long. So that's why you take stuff you learned in 2420 and put it to use. Design an efficient implementation. Deal with those things quickly. All right, so just take that to heart when you're reading about, trying to figure out how these things work. All right, so we're going to talk for a while today about debugging. And apparently, we're often taught as computer scientists that Grace Murray Hopper invented the term from a moth that got stuck in an old computer, created a short circuit. And in fact, I believe it, if you go to the Computer Museum in the Bay Area, that the original logbook with the actual moth is on display. I'm not sure it's at that museum. I know it's in a museum. So apparently the term even comes before that. So the term bug has been around for a while. And it has an unfortunate psychology. So I try to avoid saying that my program has a bug. What I say is my program has a mistake, or my program has a defect. So why is that way of expressing yourself, how's that going to change what it means to debug a program? Yeah?
The bug is more like annoying emotion. Using the term bug as opposed to mistake.
Okay. So, yeah?
Maybe saying the mistake or defect takes more accountability on myself as like it was my problem instead of just some
Right.
bug here.
Okay. More accountability.
Like when you say it like has a bug, it's like the program is doing something wrong rather than you do something
Right. So that's the way I would put it is, when you say it's a bug, it's like, the world is screwing with you, right? You're the victim. And when you say it's a mistake, it puts it on you. You made the mistake. How many of you have ever been convinced that there was a bug in the programming language? I know I have. And in my life, I don't believe I've ever found a bug in a programming language. It's always been my fault, not the fault of the programming language. But there have been times when I've just been convinced that something is fundamentally wrong and it's not my fault. Now, one thing I regret in my life, in my career, is I wish when I first started programming, I'd started writing down details about bugs. whenever I had an interesting or novel experience fixing a bug, I wish I'd written down the details so I could, look back on it and see how my problems have evolved and have stories. Because I know I'm always trading stories with people about bugs, but then a few weeks later, I don't remember them at all. So that might be something you would consider. You don't have to write down every single bug, but when you run into a really cool one, maybe note it down. Now, last year when I was preparing this lecture, I had just finished dealing with 3 bugs that had really bothered me. And so I created these slides, bug number 1, the next one is number 2, and then number 3. And I came to class and I talked about the bugs and I had the students try to figure out what was the problem, and then I told them what it had been. And so I was preparing for this lecture and I looked at these slides and I said, cool, there's bug number 1. I wonder what it ended up being the problem. So I went to the next slide and it doesn't say. I have no memory whatsoever. I had no memory whatsoever of, I remember the bug, but I don't remember what the problem was. I had to go back and look at the video from last year's lecture to remember this problem. So that's why it's important to write things down. You don't necessarily remember, you think you remember something forever and it's gone in a year. So anyway, here's bug number 1. So you all use the plugin in 2420 last semester, and it's based on a plugin that I used in 1410 called the Canvas Project Manager. And fundamentally what it does is it helps 1410 students download and upload projects to and from Canvas. So it lets them, they can start it up inside Eclipse, and it'll browse into Canvas and let them pick, say, PS3, and then it will create a zip file and import it into Canvas. And then when they want to hand in, they go the other direction. So it just helps eliminate some mistakes that 1410 students tend to make. And to do it, you have to authenticate with Canvas. So the first time you use it, you have to type your Canvas credentials, log into Canvas. And originally in CPM1, we did not save, it says refresh token. So when you log in, what the program receives is something called a refresh token. And as long as it holds that token, it can access Canvas. If you throw it away, you got to re-log in again. So in CPM1, it didn't save the token to in any permanent place. So whenever you quit Eclipse and restart it, you have to log in again. And students complained about it. So I created CPM 2.0, and what I did was, when the refresh token was obtained, I saved it into the workspace. So that as long as that workspace existed, even if you killed Eclipse and started over again, you could still get into Canvas without logging in. Nevertheless, it didn't work. Every time Eclipse would restart, the user would be forced to log in. And it took me 3 or 4 days to figure out what was going wrong. Okay? And this was 3 or 4 days I didn't have to spare. And the thing is, I was not on a deadline. No one was using the CPM. I was doing this last spring. No one was using the CPM that semester, or at least weren't using CPM 2, I should say. I didn't have any users. I didn't have to have it done right then, but I became obsessed with it. Maybe that's happened to you. You might get obsessed if there's a deadline coming up. I didn't have a deadline. I just had to figure this out. But it took me days. So what do you think? Any ideas what caused this bug? Yeah?
It was saving the hash code, not the string needed.
Okay, you're saying it was saving the hash code, not the actual string. Nope, that wasn't it. Yeah?
Was the refresh token expiring?
Well, so he said, was the refresh token expiring? The documentation said it never expires. So, but that was the message I was getting back. When I did some investigating, when I quit Eclipse and started up again, it would try to automatically access Canvas with that refresh token, and it was being told it is expired. Okay, so I knew that. Tokens expired, so what was going on? Yeah?
Could it have been something about Canvas denying the token or something like that?
Something about, well, yeah, Canvas denying the token. It was, it accepted it until I shut down Eclipse and started over and read it back from where I saved it and tried to use it again. Then it was rejecting it. Yeah?
Did it expire the token when you exited the workspace?
Okay, so he hit the problem. I spent 3 or 4 days just verifying stuff. I would look in, the token is yay long. And so I would would have the token print out when it was received. I would check the actual place it was saved on disk and be sure it was saved there. Same thing. When I restarted, I would see that it was being read in, and that it was being, it was correct. It was being correctly sent. And I did all that, and I couldn't find the problem. And then I did it all again. I said, maybe I didn't do a detailed enough job. Maybe I was sloppy. And so I kept doing the same stuff over and over again, hoping to find the problem. And I never did, not surprisingly, because the problem wasn't there. So has that ever happened to you? You're trying to debug, and you just keep spinning your wheels on the same thing. Yeah.
Yeah, I was just wondering.
Yeah. But so what it turned out to be was that CPM1, since it was abandoning the token and it was going to force you to log in next time, it didn't just throw the token away. It explicitly contacted Canvas and said to invalidate the token. Okay? That was a feature. And I'd forgotten about that feature. I didn't see it in the code I was looking at because it was run automatically. It was an event-driven thing. When Eclipse shut, it only happened when Eclipse shut down. And so I had this tunnel vision. I didn't let myself take a broad enough look. And I didn't solve the problem until I sort of, I gave myself permission to back up and think about it logically. And the logical thing, once I got out of the tunnel, was, okay, Canvas says the token has expired. It must have expired. Believe the error message. And then I say, how could it expire? And once I thought about ways it could have expired, I realized, I put that code into CPM1. I'd just forgotten about it. So that's one story. Okay, here's bug number 2. The CPM downloads a zip project, like I said, and automatically imports it to Eclipse. So when I went from CPM1 to CPM2, I didn't just, there's some changes I wanted to make, but I just refactored the code to make it make more sense to me. So I was making extensive refactoring changes. And then when I was testing it, I tried to download PS1. And PS1 is unique from all the other problem sets in that it contained an empty project. There's no source code. There's no starting point I gave the solution. So the starting point's an empty project. And it crashed. And I quickly found that when you tried to download a project, an empty project, and put it into Eclipse, that this bug would be triggered. And I figured out how to fix it right away. I figured out how to deal with this. But it bothered me that this bug had not surfaced in 1.0. Now, should I have just said, oh, it works now? Who cares why it didn't work at 1.0? I could have done that. Why would that not be a satisfactory thing to do, just to blow off the bug? I mean, fix it, but not worry about it. Yeah?
You get reoccurring repercussions?
Yeah, he said I could get repercussions from it. Basically, there was something wrong in the original program, apparently, and I didn't want to copy it forward without understanding it, because who knows how it might turn up later. But no one had ever reported this bug with CPM1, right? People had used the original CPM, downloaded PS1, no problem. And so I thought I've introduced the bug when I've been refactoring. And so I started laboriously comparing code and figuring out, is it really doing the same thing? And again, spinning my wheels over and over again, because I was too focused, I had this preconceived notion. Then when I finally backed off, I realized what the problem was. Any ideas what the problem was? What would cause something like that? Why did it work okay in CPM1, but not in CPM2? No ideas? Well, here's the problem. In CPM1, what I had forgotten was I had changed the way configuration files worked. So there's a configuration file in Canvas that makes this work. And for PS1 in the original CPM, there was no project to download. And the way CPM1 worked was, if there's no project to download, it created an empty project. It didn't download it and import it. It just created an empty one directly. So the bug was there all along in CPM1. It just was never exercised by PS1 because it was worked around differently. But again, that was, I didn't get this until I backed up and started thinking logically about what was going on. The other aspect of this bug was, at the time it seemed, I had the working CPM1, a student had created it, and I didn't feel like creating recreating the getting the source code and directly debugging CPM1. Then I would have found the bug that way. I was too lazy to do that. So I just assumed something about CPM1 that wasn't true, mainly because I wasn't using good version control. All right, one last one. You know, we live stream these lectures, and we have problems all the time. Last year, we were live streaming these classes, and Stefan, who was doing it, told me that every 5 seconds, the audio was dropping out of our video. So we're making these videos, and we thought we had got all the trouble out, and then he says every 5 seconds the audio drops out. And we worked and worked and worked on this, you know, setting up after class to test it. We couldn't reproduce it in class, in our tests, but when he kept telling me that audio was dropping out every 5 seconds like clockwork. What do you suppose was causing that problem? Yeah?
Was it the hardware?
Well, that's what we thought, was it the hardware, so we tried, but the problem is we couldn't get the hardware to misbehave when we were testing it after class. Yeah?
Maybe like a volume detection threshold?
A volume detection threshold? Perhaps, but again, unless I'm talking differently in class than when I was testing it afterwards, that doesn't explain it. Yeah?
What were you using to record the audio?
Like here, the camera has the mic and then it goes to the computer and it ultimately gets uploaded to YouTube. Yeah?
Was it out of memory error?
It wasn't out of memory error. Yeah?
Was it a compression error?
It wasn't a compression error. Yeah?
If you're using OBS and it's set to system default, then the system might be flipping between default and its own mic.
Okay, so OBS is the software we use, but no, that wasn't the culprit either. Yeah?
Didn't have exclusive control over the microphones?
He said didn't have exclusive control of the microphone, that wasn't it either. So this is what it was. So Stefan was in my office sometime later, and he was listening to music on his phone, and he noticed that with his Bluetooth earphones, and he noticed that he lost this audio in his earphones every 5 seconds. The bug was in the Bluetooth on his phone. That's how, in class, that's how he monitored the audio. He would sit there with the headphones in, because he didn't want to play the speaker on the computer, and he would hear it drop out. But when we tested after class, we were just listening to the speaker on the laptop. So, what do all these bugs have in common?
So it was hardware as user.
Yeah. It can be the thing you least expect. And in all three of these cases, we were working really hard to figure it out, but we weren't looking in the right place. We got too wrapped up, too absorbed in what we were doing. And it wasn't until, well, that thing was actually an accident, the thing about the sound dropping in and out, when we put it all together. But it wasn't until we realized that we have to step back and think about it logically and really stop zeroing in on something that's not working, that we're able to solve those bugs. And that's not to say I don't write bugs with garden variety problems that are easy to find. These are the ones that stick with me because they took days or weeks to figure out. Okay, let's take a break and then we'll continue. Okay, so I've told you my stories about debugging, and I'm sure you all have similar stories that, things that have happened to you. And this first point is, why is debugging a difficult task? And it says there, most programs aren't very systematic about it. Okay? What do you do when you have a bug?
Open the debugger.
Okay, that's good, because a lot of students don't do that. At least what the TAs tell me. What do you suppose the TAs tell me, how students debug? Not even that. You call a TA. Okay? So if you use a TA as your first recourse for debugging, you will never get good at debugging. Okay? And so now is a good time to start weaning yourself off of TAs. Learn to get good practice. One thing you can practice. Now I know it's hard to practice on a deadline, but practice debugging to the extent as you can. When you get stuck, it's good to talk to other people, but at least give it a try. Programmers learn one technique and stick with it. So, they start debugging by printing stuff to the console, and that's all they ever do. That has its place. I do that when I've got a program and it's just too laborious to step through it and look at things. I sort of want to get a quick glance at what's going on. But that's not the only thing that I do. And it's difficult because software is difficult. Everything's hard. Another thing about debugging that makes it scary, especially again, you've got an 11:59 p.m. deadline, is it's hard to say how long it'll take. Those bugs I just showed you that took me days, I didn't think they'd take days when I started. I thought, I'll have this done in a few minutes. But a few minutes turned into a few days. And that's scary when you don't know how long it'll take. It just takes as long as it takes. All right, now, if I ask this question, what is the result of successful debugging? A lot of people might say a fixed bug. The bug is gone. But what I'm saying here is that what you should produce as a product, first of all, are test cases that reveal the defect. So when you have a problem, one thing that you need to have is some test cases that are failed because of the problem. Why is that important to have test cases? You don't just want to observe the bug and say, oh, I got to fix it. You need to produce some test cases that trip the bug. Yeah?
It helps you get through the hypothesis so that you can get to a specific.
Okay, so it helps you test your hypotheses. So it gives you a way to tell when you fixed it, right? It's an objective measure of whether your program still has that problem. When you finish repairing a bug, you want to have commits of the original program and the repaired program. So it's good to see what it was like before, what it was like after, then you got a record of what you changed, what repaired the bug. That way, if later on the bug recurs, you've got some fighting chance of figuring out what you did the first time. And if you can be that introspective, if you write down a note every time you fix a bug, you start to notice patterns. You start to notice that you're prone to making the same mistakes over and over again, and you can train yourself to stop. And I'll tell you one that I make still all the time. When I write a nested loop, let's say I'm iterating I, and then inside I'm doing j. I tend to write for int I equals 0, I is less than n, I plus plus. And then the inner loop is going to be for int j equals 0, j is less than m, I plus plus. So I increment I in both places. I'm constantly forgetting it's j plus plus. I can't tell you how many times I've made that mistake. But I've gotten to the point where my memory is tripped when I'm writing a nested loop, and I remind myself as I'm doing it, don't make that mistake, don't make that mistake. So if you can start to see patterns in the kinds of mistakes you make, you can have a better chance of avoiding them. Now, to make debugging rarer and easier, you follow best programming practices. When we say things like instance variables should be private, one reason we say that is that it's shown with experience that public instance variables tend to be a source of bugs. Poorly named variables tend to be a source of bugs. Uncommented code. tends to produce bugs. So the more hygienic you are about producing well-structured code, easily understood code, the fewer bugs you'll make, and the easier it's going to be to find them when you're done. Another thing you can do is heed Judy's law, and I'll explain what Judy's law is on the next slide. Now, what you should not do is just guess at what the problem might be, or randomly scatter print statements in your code, or step through your code just to see if anything pops out at you. You should not get rid of old versions of your code. Because let's say that your program is working perfectly fine and now it's stopped. Well, if you made a commit recently, it worked when you committed, and now it doesn't work, you can just do a diff between the two commits and see what you changed. But if you just, what I do all too often is I'm just overconfident and I'm just changing stuff and I know it'll work and then the bug happens. I got no way to see what I even changed. I can't remember what I changed. I found myself in the editor saying, oh, I've messed up, I didn't create a commit. And I like doing Control-Z like 100 times to try to get back to the point where it worked. And another thing you shouldn't do, as we said, is blame somebody else or something else. Don't blame the compiler or the linker, Visual Studio, Microsoft. It's almost certainly your fault. Okay, this is Judy's law. Judy's law, you won't read about in any book anywhere, because Judy is my wife. This is her law. And she was, for a long time, a software engineer. So this came out of her software engineering practice, but it applies to everyday life. And so what it says is, something seems wrong, but you dismiss it. It will come back to haunt you at the worst possible time. So if you notice some anomaly, the tempting thing to do is say, did I really see that? And like, this happens a lot when you're just watching your program run. And something doesn't make sense. And you say, whoa, that's weird. And you run it again and it's not there. And you say, oh, I didn't really see it. And I do that a lot. I didn't really see what I thought I saw. It was just a glitch. It won't happen again. It only happened because some server was down. You can think of a million explanations for why something happened and then it didn't happen again the next time. The puddle under the water heater is condensation, when in fact the water heater is failing. So that's where it comes back to bite you. You come down, your basement's flooded because you just blew off the condensation. So don't rationalize. Her way Judy does Judy's law is, she says you got to stop right away and figure out what's going on, or what will happen. I mean, what will happen if you don't figure out what just went on? You just ignore it.
You're going to keep testing it, and it's going to keep being fine, and then you're going to leave it alone.
Yeah.
It's going to break.
Yeah. So what always happens, what he was saying is, it didn't happen, and so you sort of forget about, I've done this many times, I forget about the fact I even saw the problem, and then a month later, the program catastrophically starts failing, and I spend days debugging, and then I realize that if I just fixed it the first time I saw it, I realized, oh yeah, this is that thing I saw and forgot. If I'd only fixed it then, if I'd made a note of it then, it would have saved me all this debugging effort. So at least note the problem and investigate. Do it while it's fresh on your mind. Okay, so you can take a scientific approach to debugging. And the scientific method involves making hypotheses and then designing experiments to either confirm the hypothesis or to falsify it. And that's basically what the deal is. So what you want to do is, if you want to spend 5 minutes just stepping through and hoping to have inspiration hit, that's fine. You can, or just stare at the code and find the bug. If you can do that in a few minutes, that's great. This is advice for what you do when it defies a quick solution. So stabilize the error. You've got to be able to reproduce it. So ideally what you do is, first of all, make a commit of your program that has the bug. You want to simplify the program as much as you can and still have the bug. You want to create test cases that reliably show the bug. So you've got to get it where you can reproduce the bug, and you've got test cases that show the bug happening every time. Now you've got to locate the source of the error. And here, I can only give you fuzzy advice. You look at all the available evidence, the tests that are being failed, the stuff that's being printed to the console, anything you've observed, and you've got to come up with an hypothesis. So when I described my bugs to you, lots of people were willing to say, oh, maybe it was this, maybe it was that. And That's what you have to do. You have to come up with a reasonable explanation for why what's happening is happening. And then test it. You've got a theory about what's happening, verify it. So create a test case, use the debugger, examine the code, whatever. But your goal is to prove or disprove the hypothesis. And just keep repeating till you find the error. So don't just blindly look. There has to be an explanation. Come up with one. Even if it's wrong, when you devise a test case to show that it's wrong, you've narrowed down the set of possibilities. Okay, now once you've found the problem, you need to repair the program. Now what's the difference between repairing the program and patching the program? Yeah?
Repairing, you actually fix the problem, patching it could be partial.
Okay, so we said repairing it, you fix the problem, patching it is partial. I guess the rule of thumb is try not to make the program more complicated than it was before. So let's say that you've got a method and it always screws up when the parameter is 17. Okay? And so you find, what you do is you just put in an if statement. If the input is 17, do this, else do all this other stuff. So you've sort of patched over the problem. But you've made the program more complicated. People that come after you will wonder, why is this special case for 17? So it's much better, rather than have that special case, to actually repair the code in an organic fashion so that it's, that your program makes sense. Next, you want to test the repaired program against all the test cases. So not just the ones that it failed. You have all these test cases that a program was passing before. Make sure it passes all those test cases still. And then you need to commit all this stuff. And then at that point, you might ask yourself, I wonder if I made a similar problem elsewhere. So you might spend a few minutes looking for similar errors. And, I already talked about that. If you can find it in yourself, keep a journal. I could write a book. And this is, the slides start getting a bit repetitive here. But you need to find the error, it just takes data. You've got to test your hypothesis. You've got to refine the test cases. You've got to, you can start removing code from the program just to try to isolate things down. Brainstorm, talk to other people. That's a good thing to use a TA for. Not to find your mistake, but to suggest what your mistake might be. Code that has errors before. Why should we be suspicious of code that has had errors before? Obviously, you're worried because there could be more, but essentially, maybe that error, if it's had bugs before, it was probably poorly written. And if it's been fixed, maybe it was poorly patched. So you could easily have a code. Check code that's changed recently. So you can tell that from your version control. You can get it to show side by side what changed between two commits. See if the error exists in an older version. And then go back to an older commit and run the current test cases against it. See if that problem exists there. And we talked about repairing the program, not just patching over. And always keep in mind that there's a logical explanation for what you're seeing. This is not the universe being mean. It is just a mistake you made. The more experience you get, the easier it gets, but it doesn't get completely easy. Take periodic breaks so you don't get too zoned in on things, and talk to a Furby. Now, I think Furby's from the 90s. You know what a Furby is? Like talk to a teddy bear or something. During the break, I had someone come up with a problem and explained it to me. I did not open my mouth. And he solved his problem and thanked me and sat down. I might as well have been a teddy bear. So. Lots of tools you can use. Your brain is the most important. We've mentioned all of these. Visual Studio is full of things. In the lab tomorrow, you'll explore some of the things in Visual Studio. There may be windows you're not using. This is one, IntelliTrace. IntelliTrace, the way it works is, it automatically at certain times will take a snapshot of the program. So when an exception is thrown, it'll remember the entire state of the program at that point. And after the program is ended, you can just say, oh, go back to that point. And it'll reconstitute the state of the stack and the values of the variables and let you explore. So that can be very powerful if you learn how to use it. All right, so just some tips. You'll be getting lots of practical experience, I promise, this semester. All right. So the last topic I want to talk about is more of a programming topic today, and we'll continue this next time. And that's regular expressions. So, how many of you consider yourselves solid at using regular expressions in programs? So just a handful. How many of you have ever used regular expressions in a program? Okay, a good number of you. And you probably noticed that the formula class that I gave you to work with contained regular expressions, although you really didn't have to use them. You didn't have to understand them or change them. But regular expressions are a really powerful programming technique. And it's well worth your time learning to use them so that when the time comes that you need them, that you're not, I often, until I got comfortable with regular expressions, I would always think, well, I should use a regular expression here, but it'll take a while to remember how to use them or figure out how to use them, and I'll just do it some other way. But when do you use regular expressions?
Pattern matching.
Pattern matching, when you're looking for patterns. And you can do without it. You can write complicated ifs that iterate through strings and look for certain patterns. But suppose you're trying to find all social security numbers that are in a document. What pattern are you looking for? 3 digits, a hyphen, 2 digits, a hyphen, 4 digits. That pattern. You're all capable of writing code to do that, but once you learn how to use regular expressions, you won't consider doing that. You'll just write a regular expression. Regular expressions are for describing patterns. You'll write a regular expression that will match a social security number, and you're off and working. So let's spend some time learning about regular expressions, and you'll eventually be using them in the spreadsheet program. So first, some definitions. So I'm going to call a language to be a set of strings, possibly infinite. So for example, there's a language. Lowercase letters is a language. There are 26 strings in that language. Okay? There's an infinite language, non-negative integer numerals. Okay? What would you call that language? Spreadsheet cell names. Sure, that's a language. The set of all C# programs is a language. Now, a regular expression is a pattern that describes some language. So a regular expression would be something that would describe every string in that first set and no other strings, or every string in that third set and no other strings. So it would essentially say, okay, a spreadsheet cell has to start with with one or more capital letters and be followed by one or more digits. And the first digit can't be 0, something like that. So that's what they are. Now, not every language can be described with a regular expression. Some patterns are too complicated to describe with regular expressions. Of the ones up here, which one is too complicated to describe? Set of all C# programs. You can't describe that with a regular expression. You have to use other techniques. So what you'll see is a regular expression is a string that mixes plain text with special characters. So let's just go through them here. Here's the first example of a regular expression, hello. It's just plain text. And that just describes the string hello. So the language this describes is this set right here. The set containing the string hello. That's the simplest regular expression. So if you were trying to find an occurrence of hello in a string, there's where you probably wouldn't bother with a regular expression, maybe. Because, you just do there's an index of method in strings you would use. Okay? Vertical bar is a special character. That means alternative. So this says a string will match this pattern if the string is this or is or test. So these are the 4 things that match that regular expression. So now you know, vertical bar means something special. Here, same deal is going on, but I'm using the parentheses are special characters that are used to group. So this says that any string will match this if it begins with DO or FA or HA or JO and ends in T. So it matches those 4 strings. Here's a special construct. That's called a character set. So that says the thing in square brackets here will match any character that shows up in here. So it'll match a D, an F, an H, or a J. So we get the same language. Yeah?
On the grouping, you said it starts with and ends with. Could there be something, would it accept something with
Yeah,
more letters in between the two beginning?
sure.
and
If
end?
we wanted to have other things, we put more things between that paren and that T.
But it has to start specifically with those two letters,
Yeah.
and then the following letter has to be a T.
This particular regular expression is saying, first you got to match this thing, which will only be matched by these 4 two-letter combinations, and then it has to be a T. Okay? Here's a character range. This says lowercase a through z, followed by 1 through 9. This is negative character class. This says anything but A, B, C, followed by 58. This says anything but A through M, followed by X, Y, Z. And what does this say here?
A to Z followed by one or more, is that just 0 through 9, right?
Okay, so star, I guess I gave a star too quickly here. Star means 0 or more repetitions. So this says a single lowercase letter followed by 0 or more digits. Star means 0 or more repetitions of the thing that came before it. Yeah?
Why does it parentheses?
Parentheses just used for grouping for the same reason. There's another use we'll talk about later. There's precedence rules in regular expressions. So I just do this to make sure that the star is applying just to the 0 through 9 and not to this as well. They may not be necessary here. Just like I don't have all the Java precedence rules memorized, I don't have all the regular expression precedence rules memorized either. Okay? Question mark means optional. So that 0 question mark 1, 2, 3, 4 says 0 or not, followed by 1, 2, 3, 4. Star means 0 or more. Plus means 1 or more. So star and plus work the same way, except with plus you got at least to have 1. So this says you have a 0, followed by 1 or more 5s, followed by a 1. And then there are things like this says, this says exactly 2 occurrences of this. So A, B, B, B. This says between 1 and 2. This says 2 or more. So, this is just a list. I don't expect you to memorize the list, but I expect you to realize, I guess I expect you to remember some of this list. You know that you've seen these things before and that you know how to use them. Now, all the lists in the world won't help very much unless you just roll up your sleeves and start trying them out. So let's do that. What I highly recommend is that you go to a site like this one. This is regex101.com, and it just lets you experiment with regular expressions without having to go through the pain of creating a program to use a regular expressions. Because there's 2 sides to regular expressions. There's writing regular expressions, which works pretty much the same no matter what programming language you're using. And then once you have a regular expression, there's using it in the program, and that differs. The way you use a regular expression in Python is different from C#, is different from Java. Libraries are just different. But the regular expression, the thing I just showed you, is the same across languages with minor differences. So right here, we can choose between using PHP-style regular expressions or JavaScript-style or Python or Go. And for our purposes, it really doesn't matter. The difference is in the really obscure corners of the regular expressions that we're not even going to touch. So let's just spend the rest of class just experimenting a little bit with regular expressions. And next time, we'll see how to actually use them in a program. So let me blow this up a little bit. So let's write a regular expression that'll match the string hello. So what was that? It was just hello. And then down here I can type a test string. So I say this is a test. It doesn't matter if I screw up. Hello there. And so what it's doing is it's just looking in that string for something that matches hello. And again, you can barely see that. You'll just have to take my word for it. Maybe I'll just turn the lights down. You'll be able to see it better. All right. You really can't see it any better, can you? Can you see where it's highlighted there? Yeah. Should I leave the lights down? I need something. Anyway, there it is right there. Well, that makes it a little darker, doesn't it? So that's the match. Okay, and if I put another hello in here, it will it'll notice it, and if I say, it'll find it no matter where it occurs. So right now it's set up to find every match in this string that I'm typing. All right, let's write another regular expression. What would be a regular expression that could match any positive integer?
Valve, or, oh,
0 through 9 star.
Okay, so one way is 0 through 9 star. Now, I got some exception to take with that. What's not quite right about saying 0 through 9 star? Because that will match an empty string, right? And that's not a good integer. Got to be at least one digit. So how do we make it say it contains at least one digit? We just say plus. So now it'll match. So if I type 1, 2, 3, 4, it'll match that. So it'll match any of those things. Now, I don't like the fact that you can write a number that starts with a 0. This regular expression matches that. How can I write a regular expression that does everything this one does, but it won't match a string that starts with a 0? Okay, so we can say it begins with 1 through 9, and is followed by what? 0. In this case, we won't 0 or more, because it's okay to have a single digit. So the first digit has to be 1 through 9, the last digit 0 through 9, and 0 or more of those. I shouldn't say last digit. And you see it matched 1, 2, 3, 4, 5, 6, 3, 5, but then in the thing that starts with the 0, it only matched the 6, that part is all that's being matched. And you can look over here and see what's being matched. So we'll show you what's being matched. Okay, what if I'd like to have negative integers as well? How could I have an optional negative sign? Okay, so let's try that. So it matches that. Let's see if it'll match a negative number. So negative 78. Yep, that works. What if I want to have minus or plus? I want to be able to have a leading plus sign.
You have to use the escape character, otherwise.
Yeah, I'm wondering about that. Let's see. I bet it worked though. Yeah. Okay. And the reason he said about the escape is, remember, negative is a special symbol, right? The hyphen right there between the 1 and the 9, that meant range. And the plus means 1 or more. So sometimes it's possible you want to use if you want to have a question mark literally here, if you really meant, I want a minus or a plus followed by a question mark followed by digits, what you have to do is escape the question mark. So you just put a backslash in front of it. So now it's taking it literally. So you can see it matches none of these anymore. But if I put a question mark here, with a negative sign in front, I guess, now it'll match it. So sometimes you have to escape. Now why didn't I have to put escapes in front of the minus and the plus?
Because they're in the brackets there.
You might have thought you have to do this, but it just turns out that the way that I happened to use them in there wasn't any confusion. So no need to do that. Okay, so you see the game that you play. Let's do Social Security number. What regular expression would match any Social Security number?
0 through 9.
Okay, so we got to have 3 digits. So while we're on the subject, I'll just tell you, \D will match any digit. Okay? So that's shorter than doing 0 through 9. So a social is just /D/D/D. And that will match, so it's matching none of those things, but it will match. So it finds the match. Okay? So regular expressions really aren't tough. What you want to do when you're using regular expressions is debug your regular expressions in something like this. Make sure it works like you're expecting. Then you copy it and paste it into your program. Let's do one more. What about a decimal number? I want to have something like, I want to match all these things. 23.45, 0.68, 18 point. and just that. So basically an optional decimal point that can occur anywhere. All right, so backslash D star, let's say, followed by a dot, followed by what?
Question mark.
Followed by
You want to make that optional?
slash D, so.
Actually, let's make it simple to start with. Okay, what about that? That says 0 or more digits followed by a decimal followed by 1 or more digits. So it matched everything except it didn't match the 18 dot. It didn't match the dot in the 18. Because I'm saying there has to be at least one digit after. So what would be a regular expression that would do, that would allow you to have, require you to have a digit before, but no digits after? Or require a digit before and then 0 more after. What would that look like?
Add a slash D, /D to the asterisk.
Yeah, well, we could just do this. Sort of the opposite. So now it's matching everything except the 83 by itself, and then we could do or. So that's one way to write it. Why isn't that? Problem is it's doing some over. It's confusing. Let's look over here. It matched 23.45. It also matched 23.4. So it's sort of finding multiple matches in each full match. So there it's matching 0.68. So I've done something wrong. Why is it matching a space? Oh, I didn't put an or. Yeah. Okay. I was trying to give 3 alternatives. I just gave 2. Okay, so it matched 23.45, 0.68, 18, 83. It didn't match 18 point. Huh. Why wouldn't it match 18 point?
Why would it not?
Yeah, why is it not matching, right there, it's not matching the decimal point in the 18.
There's no optional point. I think that you added an optional point on the very
No,
last.
but I'm saying 1 or more digits followed by a decimal followed by 0 more digits. I screwed something up. I'll debug that. So
There's a white space here.
we'll continue this next time.